Hello, welcome to Agronomy for Future. This YouTube channel is linked to Agronomy for Future website. For more details, please visit agronomyforfuture.com. Thank you.
Hello, welcome to Agronomy for Future. When we set up our experimental design, it is not easy to decide the sample size because we don't know exactly how many samples are required for our experiments. Of course, the more, the better. However, eventually, we need to decide appropriate sample size according to our time and resources. For example, if we want to know the average height of students in University of Guelph, the best way is to measure all students' height. According to Wikipedia, the total number of students in University of Guelph is 29,923. So, if we measure 29,923 times, we'll get to know the exact mean height of the students in University of Guelph. Does that make sense? No, it's totally nonsense. We should estimate the population from sampling. Therefore, the main question would be how many samples are necessary to estimate the population. Here is one example. There is a corn variety which is commercially used. One agronomist wants to know there is a difference in ear dry weight per plant between two groups according to different nitrogen conditions. So, he investigated ear dry weight per plant in two different nitrogen conditions as Group A and Group B. Now, he wants to compare the mean of two groups in order to know which group has greater ear dry weight per plant. In this case, two sample t-tests would be used to analyze the data. So, now he wants to know how many samples are necessary to conduct two sample t-test. In R, we can use this code to calculate sample size in two sample t-test. The effect size can be calculated as dividing the difference of two groups' mean by pooled standard deviation. This is two different groups, and therefore we need a common standard deviation, which is able to be applied in both groups. This is a formula to calculate pooled variance between two groups. Standard deviation is the square root of the variance. So, after calculating pooled variance, we can simply obtain pooled standard deviation by square root of the pooled variance. First, let's calculate pooled variance between two groups. The pooled variance is 2.463. Then pooled standard deviation will be 1.57. Now we obtained the pooled standard deviation, which is 1.57. So, we can calculate the effect size like this. Now it's the time to calculate the sample size. In a given effect size, which is 1.53, I set up significant level as 0.05 and power of test which is 1 minus beta as 0.85. If we increase power of test, the area of alpha will be increased, indicating type 1 error, which is also known as alpha error, is increased. It means even though null hypothesis is correct, we reject it. I'll explain again about this. As an independent researcher, you need to decide the power of test based on your data, but normally, I set up 0.85. This is the comparison between two independent group, and therefore it's two sample t-test. Also, this is about the same or not the same. So, alternative is equal to two-sided. R calculated the sample size. In each group, 9 samples are required. So, in total, 18 samples are necessary to compare the mean of two group. The agronomist collected 4 samples per group, and he would need to increase sample size more than twice. As another method to determine sample size, I'll introduce G-Power program, which is the most popular software to calculate sample size. First, in test family, select t-tests and choose mean. Difference between two independent means, two groups, which indicates two sample t-test. Now, we need to input several values, but we already know what it is. Sometimes, People who cannot understand the effect size simply accept the effect size among 0.2, 0.5 and 0.8, which G-Power provides as a guide. It's totally wrong. You should calculate the effect size based on your data. It's simple. We already calculated using this formula. G-Power says we need 9 samples per group, and in total 18 samples are required. This is the same as R calculated. Actually, when using G-Power, we don't need to calculate the effect size because G-Power automatically calculates it. In the main window, when you select the button, Determine, new sub-window opens. When the sample size is the same, only input, mean, and standard deviation of each group. Then click the button, Calculate. You can see the effect size is approximately 1.53, which is the same value we calculated. You can simply copy this value as clicking the button, Calculate, and transfer to main window. In the main window, click the button, XY plot for a range of values, and then click the button, Draw plot. G-Power provides the change of sample size according to power of test. When power of test is 0.85, in total 18 samples were necessary, but if power of test is 0.95, we need 24 samples, which means 12 samples per group. When power of test increases, beta will be decreased. When beta is decreased, alpha will be increased. Alpha and beta are mutually opposite. Due to increased alpha, statistical significance will be increased. Think about that. Your p-value was 0.75. So, we say it's not significant when alpha was 0.05. However, when you set up alpha as 0.1, your p-value becomes statistically significant. When alpha is increased, statistical significance is also increased, but type 1 error, also known as alpha error, is also increased. Under alpha is 0.05, you reject alternative hypothesis as p-value is 0.75. But under alpha is 0.1, you'll reject null hypothesis. Even though null hypothesis might be correct, but due to increased alpha, you'll take more risk to reject null hypothesis. Increased statistical significance will result in more chance to reject null hypothesis and accept alternative hypothesis. Therefore, it would require more sample size in order to compensate the increased statistical significance. However, there is no answer about power of test. As an independent researcher, you should decide the sample size based on your own data. You can choose power of test based on your data, and also you might be able to take more samples if you can manage. When power of test is 0.85, you need 9 samples per group, while you need 12 samples per group when power of test is 0.95. You can adjust sample size based on your capacity. However, the most important thing to determine sample size is not power of test itself, but the data variability. Here is another data. The agronomist found some plants have extremely low ear dry weight, but he accepted these plants too and calculated sample size. Then, how many samples would be required? In each group, extreme outlier exists. In total, 826 samples are required. Due to higher data variability, much more sample size will be required. In this case, deciding power of test would be meaningless. Even though we decrease power of test, we need lots of samples. What I want to indicate is that power of test is not the main factor to determine sample size. It's just a statistical guide. However, data variability would be a critical factor to determine sample size. So, what should we do? Always monitor outliers in fields and decide whether or not to include or exclude the outliers. Agronomy research is to cope with outliers in fields. For more information, Please visit agronomyforfuture.com. Thank you.